Hello everybody, this is Matt TV, and today we're going to be attacking the 2024 AMC8 problem 23. The question reads, Rodrigo has a very large sheet of graph paper. First, he draws a line segment connecting point 0.04 to point 0.20, and colors the four cells whose interiors intersect the segment, as shown below. Next, Rodrigo draws a line segment connecting point 2,000, 3,000 to point 5,000, 8,000. How many cells will he color this time? So, the question gives us a smaller case, 0.420, and then a bigger case that we need to solve for. So usually in these type of problems, what you want to do is find some kind of formula or generalization that we can use to solve the big problem. Because obviously we're not going to draw 2,000, 3,000, and 5,000, 8,000. That's just too big. We don't have that large sheet of graph paper. But we can draw 0, 4, and 2, 0 and see, okay, what is a pattern here? So oftentimes the coordinates, if the problem doesn't actually ask you to do anything with the coordinates, what you can do is simply take the side lengths. So, for example, in this case, it's a rectangle, so we can take the sides of 2 and 4. And this is very easy to simplify the problem to make it much more solvable. So now, instead of drawing a whole coordinate plane, we can simply draw a rectangle and see where we go from there. So 2 by 4, that means that it's going to be 1, 2, 3, like that. So when we draw the line, which passes through here, we see that it passes through these four. 1, 2, 3, 4. And the formula to get this is actually very, very intuitive. What we do is we take the sum of these two first, right? The sum of these two. So the 2 plus 4 represents the sum of this width and this length because it will be going through, these 6. And now what we want to do is subtract it by the GCD of 2, 4. So GCD of 2, 4, let me write that. GCD of 2, 4. And in general, to solve these types of problems, you always want to do something with the GCD because the GCD gives you the number of overlaps that this line will have, which will intersect at a lattice point. And this lattice point will make sure that this doesn't actually intersect an interior of a cell. It rather just intersects at an integer coordinates where it doesn't intersect the interior at all. And as you can see here, this actually causes us to subtract these two cells right here. So that's why we do this. And we can test it out in another scenario. Let's say a very simple case. Let's just say 2 by 1. So as you can see here, 2 by 1. As we can see here, if we just draw a line, we see, okay, 2 plus 1 minus GCD of 1, 2, which just gives us 3 minus 1, which is equal to 2. So as we can see here, it does actually intersect in two cells. So in general, the formula is always just A plus B minus GCD of AB. And if you want, you can also try testing it out on many other side values. Just make sure to draw it nicely so that you'll see where exactly it intersects at the lattice points. Now we can use that formula to attack this, 2,000, 3,000 to 5,000, 8,000. So as I said before, what we want to do is instead of caring about the coordinates so much, we can actually care about the side lengths only. So 2,000, 3,000 to 5,000, 8,000, what is that? Well, 2,000 to 5,000, that is 3,000. After that, 3,000 to 8,000, that is 5,000. So now we want to find the number of cells to color this time in the 3,000 by 5,000. And we can simply use the formula, 3,000 plus 5,000 subtracted by GCD of 3,000, 5,000. And from here, it's pretty obvious that since 3 and 5 are relatively prime, that the greatest common factor of this is simply 1,000. And you can also just prime factor each one and use the bucket method that I've covered in the previous video to solve for the GCD. But after that, we get 3,000 plus 5,000 minus 1,000, which is equal to 7,000. And that is our answer. So remember this formula of A plus B minus GCD of AB. As it is super useful to find the number of cells that are colored. And remember why we do GCD of AB. It's to find the number of overlaps, and we have to subtract the overlaps because they had a lattice point which is not intersecting in the interior of a cell. So without further ado, thank you for watching this video. I hope you enjoyed. May the force be with you. See you next time.